In this video, we present a quick overview of our dummy positioning capabilities. With HyperWorks, you can position your dummy manually or fully automated in batch mode with respect to, for example, measurements from test labs. The interface allows graphical picking of desired joints and bodies and direct movement. Also notice joint stop angles. If needed, stepwise change through the entity editor or using explicit values is possible as well. While joints may have predefined min-max stop angles, you can also set up a quick contact definition between dummy and structure that will be respected when moving dummy limbs. Another functionality is the so-called move to target, where HyperWorks uses the kinematic chain of joints in the background to automatically move the dummy to a selected position. Here you can influence which joints and degrees of freedom are respected during this action. The position of the dummy can be exported to a positioning file, which can later directly be imported. Additionally, the positions can be saved and reactivated at any time, and are also written as metadata to the solver deck. HyperWorks offers several methods to fit dummy and seat structure. For light intersections, you can use the foam deformer, which automatically uses Altair solvers in the background to deform the seat foam. You just pick the relevant deformable and non-deformable parts and start the background simulation. And finally, have the result applied to the mesh. Another method is the seat deformer, to include more deformable structures and to create a runnable presimulation deck. The user can optionally edit different numerical default values before exporting as, for example, LS-Dyna or Radius model. It will be ran externally, and the final results, including element stress results, can be re-imported and applied to the structure parts. A pre-simulation can also be defined for the dummy itself, and as well as a coupled simultaneous pre-simulation of dummy and seat deformation in a single run. Again, the user has the option to modify numerical parameters for the exported deck. The movement of IR track joints is also supported. The user can also automatically position the dummy according to measurements from a test. The mapping of measure targets to dummy nodes is done, just as the import of the CSV file with the final coordinates. A subselection of target points to use in the movement is possible, and the current distance to the final position is marked with colors. Again, there is the option to specifically select the joints, bodies, and degrees of freedom that will be respected. The final movement can be started, and the full process can also be done completely in batch mode.